So this is what your table of contents page should look like so far. Now, we're going to do some graphing, but I don't want you to freak out about it. The graphing is not any harder than the stuff we've already done. You say, well, that was hard anyway. Well, it'll be all right. What we're going to do is do the transformations. You're going to learn the parent graph and then do the transformations. You're just going to learn 2 new parent graphs. That's what you're going to learn. Okay. This page that you see right here, you don't have, nor do I. We're just going to talk through some of this. Algebra is the story of functions. So far this year, we've graphed and discussed key characteristics of linear, quadratic, polynomial, exponential, logarithmic functions. Have mercy, we've done all that. Today we're going to talk about a new type of function called a rational function. Now, rational function. In English, do you learn the term root word? Is that a yeah, it's a ratio. Rat. Well, some of you might think this comes from rats. Ratio. A ratio is a fraction. So, a rational function has a fraction with variables in the denominator. Is the denominator the top or the bottom? The bottom. So, a rational function just has a variable in the denominator. That's all a rational function is. A variable's in the denominator. Now, let's look right here. A rational function is a function whose rule can be written as the ratio of 2 polynomials. Oh, so you got a polynomial in the top and you got a polynomial in the bottom. The 2x squared minus 3, x plus 4, 7x to the 5th minus 3x to the 4th plus 2x squared minus 1. Those are all polynomials. The parent functions that you're going to learn are 1 over x and, 1 over x squared. Those are the 2 you're going to learn. Today we're going to learn 1 over x. Now, right here, no. Now, this is your green sheet, I think. No. Well, it's close.
Wait, go back. Not the grass. Go back. There we go.
You do have that graph.
Yeah.
And then you have key characteristics. All right. So, let me see what this is supposed to say. Oh, I think this is already filled out on yours. I'm going to have to fuss at Miss Log about this. Rational functions like exponential and logarithmic functions have, no, it's not on there. Asymptotes. Yay. Asymptotes. So let's talk about a graph. Now you have this graph, or at least you have this, right? Now, we're going to make a table. So just go. Make a table. Well, yeah, I got some humor back there. Now, here's what we're going to do. Aiden, you writing this down? Now, here we go. If we let x equal -2, then this thing is 1 over -2. What is that number? That's -1/2. So this is -1/2. What if x is -1? Then it's just negative 1 divided by -1 is -1, right? What if x is 0? It's undefined. Can you divide by 0? No, can't divide by 0. You cannot divide by 0. No. You just abbreviate as UND for undefined. I'll show you. If x is 1, then I have 1 over 1, which is, if I have x is 2, then this is 1 over 2, which is a half. Go ahead and leave them as fractions, okay? Now let's go plot those. So I've got -2, -1/2. You're plotting them, right? No. Now, 0 undefined. Here's what that means. When x is 0, there's no y value. Holy cow. So I don't do anything at this point. Now, 1, 1, 2, 1/2. That looks funny. Now, let me ask you a couple more questions. What if x is 4? What's y? 1/4. So if x is 4, y is 1/4. Now, question here. What if x is 1/4? 1 divided by 1/4, Tree said, was 4. 1 divided by 1/4. When you divide by a fraction, it's the same as multiplying by the reciprocal. So that's 1 times 4. So 1/4, 4. 1/4, 4. Yeah. Now, you guys are trying to find a pattern. There's not one. There's not a pattern. These are. What happens to this function when x is 0? Whenever the denominator is 0, that's where you have a vertical asymptote. Oh, snap. I have a vertical asymptote when x is 0. So, right here, I have a vertical asymptote. I can't cross that thing. But what happens, look what happens. What if x is 100? And that would be 1 over 100. So if x is 100, how far would I go up? Barely. What if x is 1,000? Barely go up. What if x is a bajillion? I'm still going up, right? You can't tell, but I'm still going up. So, long story short is, do I ever touch the x-axis? No. The x-axis is my horizontal asymptote. Oh, stop it. Now, this piece is going to look just like this piece, except it's down here. This piece looks like this. Now remember, you don't touch the asymptotes. My horizontal asymptote is the line y equals 0. Sure can. You don't like that the paper is green. Well, oh, well, okay. Now, this piece down here is not on your paper. All the other functions we've studied so far this year are what we call continuous. Do you know what continuous means? Yeah, it means that if I start graphing it, I never have to lift my pencil ever, ever. Do I have to lift my pencil when I'm graphing this one? If I start here, I graph and I graph and I graph and I graph and I graph. How do I get over here?
You just go around.
I have to lift my pencil. Lifting your pencil means the graph is, oops, yeah, is discontinuous. When you have to lift your pencil, the graph is discontinuous. This is an example of what we call a hyperbola. A hyperbola. Now, each of these two pieces is called a branch. So a hyperbola has two branches. Okay. Now, we are characteristics, right? Okay. Graph is called a the graph is called a hyperbola. It's called a hyperbola. It does. It does. Now the vertical asymptote, you may have already written that in there, right, Lance? Keep your. Didn't you learn in kindergarten to keep your hands to yourself? Smart Alec. Horizontal asymptote, y equals 0. That's talk, domain, and range. Now, let me ask you a question. Are there any x values that I cannot put in there?
Yes.
0. I can't use 0. Could it be negative? Sure. So, anything but 0. That's what that says. That says the set of all x such that x is not equal to 0. When you need all of them but just a few or one, you can write it like this. You having trouble with the little doodad? I've been drawing these for a long time. The range. Yeah, look, right here. Y is -4. There's y -3. There's y equal -2. There's y equal to -1. As this goes up, there's y equal to -1/2. Here's y equal 1/2 out here. Here's y equal 1. Never touches 0. Don't know why I didn't just erase on this one. That's the truth. That's the truth. Now, I want you to write down in the space that you have below. Have you already glued that in? Below the box, down here. Everybody see? Below the box. I want you to write this. F of x equals a over x minus h plus k. Write this on the bottom of the green sheet. Below the box. A over x minus h plus k. No. Every piece of this is something you already know how to deal with, I promise. It is. Now look, A I want you to draw an arrow to the A. That is a vertical stretch or compression. A vertical stretch or shrink. That's right. So have you got that written down? A is a vertical stretch or compression. Now here's something that Aiden just mentioned. If A is negative, what does that tell you? Reflect over the x-axis. Yeah. I'd write, yeah, reflect over the x-axis. Girl. Now let's talk about the H. In with the H, excuse me, fiddle. In with the X. Remember, in with the X means horizontal. So I want you to draw an arrow to the H. And I want you to put left or right. Outside, not with the H, or not with the X. So up or down, yep. I'm going to give you a piece of graph paper. We're going to do 5 graphs, and we're done. So we're finished with the green sheet, so go ahead and tape or glue that into your notebook, and then you're going to take a piece of graph paper and fold it into a Z. Okay, this is your first one. So over on the white, beside the first grid, I want you to write f of x equals 1 over x minus 3. Now notice what it says. List the transformations, the domain and range, and the asymptotes. Label or make a table for at least. Now you're going to think this is a lot. But just humor me, right? Okay, just humor me. What I really want you to do somewhere on this page, and I don't know where, you might even do it on your desk. Well, you don't have the markers. What we want, let's put y equals 1 over x so that we can refer back to it. So it's essentially the table that you've got on your green sheet, and you may just want to just look at the one on your green sheet and not rewrite it. Okay? So if I use -2, -1, 0, 1, and 2. Now these numbers were what? 1 over -2, 1 over -1, 1 over 0. That one was undefined, and that one was 1, and that one was 1/2, right? We're going to put, let's put a couple others in there. Let's put in, let's see, you had some others, didn't you? 4 and a 4th. Okay, so let's put in, well, snap. So let's do this. Almost. 1 divided by -1/2 is the same as 1 times -2. And then let's stick in 1/2. 1 divided by 1/2 would be 2. That'll give us our 7 points, and that'll give us plenty to have a decent picture. Now, are you okay with where we got all these y values? Okay. Now, here we go. Now you got plenty of room. You got a lot more room to write on the white part than I do. Look at number 1. What kind of transformation? What's that minus 3 do? Horizontal shift. Which way? Right 3. So all you're going to do, right 3. Where was the vertical asymptote and the horizontal asymptote for the parent graph? The vertical was x equals 0 and the horizontal was y equals 0. Okay. If I shift to the right 3 units, does that change my x value? How? So my new point is going to be shifting to the right 3. Does that change my y value? No. Now, let's make our new chart. X, Y. But no graphing in the next unit, I don't think. Do my x values change? They change by adding 3. Do my y values change? My y values do not change. So, I didn't tell you to get a calculator, but let's see if you can handle these without a calculator. Negative 2 plus 3. What's the y value to go with it? The y value didn't change, did it? Oh, I skipped this one. Oh, snap! I should have put this right there, shouldn't I? You don't like that yellow, huh? Okay. I should only write, well, you wouldn't be able to see very well. I should have put this one down here, shouldn't I? Yeah. So let's put that one down there. So let's go to this one. What's your x value going to be? Negative 1 plus 3 is 2. What's the y value going to be? Did the y value change? No. So this is going to stay negative 1. Negative a half plus 3 is 2.5. Right. And I don't care if you put 2.5. That's fine. What's the y value? Negative 2. Y value didn't change. Now we're on this one. What's the x value? X value is 3. What's the y value? Undefined. Undefined. Here. Add 3. A half plus 3. 3.5. Y value stays the same. 2. One more. X value. 5. 2 plus 3 is 5. Oh, snap. What did I do this time? 4. Right. 1. Okay. Okay. And a half. You got to keep me going. Keep me going here. Mathis, hello. Now, this that says 3 undefined. What crap does that mean? What's at 3? What's at x equal 3? Which asymptote? The vertical one. My vertical asymptote now will be at x equal 3. Now, did my horizontal asymptote change? So my vertical asymptote now will be at x equal 3. My horizontal asymptote didn't change. Let's dot in the asymptotes. Vertical at x equals 3. Horizontal at y equals 0. Here's what I'm going to tell you. We're going to do the first two of these problems where we're going to find 7 points. After that, I'm going to cut you back to 5. Because I just want you to see it with more points here at first when you're learning. All right, plot them. 1, negative 1/2. 1, negative 1/2. 2, negative 1. 2 1/2, negative 2. 3 is undefined. 3 1/2, 2. 4, 1. 5 1/2. And that's what your picture's going to look like. Well, okay, I'm gonna turn this off and not record because I got some faces going, what?
All right, I don't know what my grade sheet.
Here we go. Here we go. Here's question number 2. F of x equals 1 over x, and then a minus 2. Now let's talk about transformations. All right. What does that minus 2 do? Down 2. So all you're going to do, transformation is down 2. Now, you're taking your graph and you're shifting it down 2 units. Does the x value change? No. Does the y value change? By? Minus 2. Yeah. So my new point would be? So I'm going to do a t-chart. Now, here's where I'm going to let's cut back to 5 points instead of 7. So let's take this one out and let's take this one out, shall we? Okay. Now let's see if you guys can keep me straight on this. Negative 2. Hey. Does the x change? Does the x change? No. Does the y change? Negative 1/2 minus 2. Good. So this is negative 2, negative 2 1/2. Let's go here. Does the x change? No. So the x doesn't change. The y value is subtracted 2. What's undefined minus 2? Still undefined. What did I just tell you a minute ago? Oh, I see what you're saying. What about this one? 1, negative. No. 1, negative 1. 1. Because 1 minus 2 is negative 1. Last one. 2. And now you don't have a calculator. I should have told you to get a calculator. 1/2 minus 2 is negative 1 1/2. Now let's talk about your asymptotes. Which asymptote stays the same? The x one, which is the vertical. So vertical is x equals 0. Horizontal goes down 2. Dot in your asymptotes. X equals 0. Y equals -2. And then let's plot those points. -2, -2.5, -1, -3, 1, -1, and 2, -1.5. You have your points kind of like so? Kinda? Now remember, when you graph these, hug those asymptotes, okay? Don't touch them, but hug them. Well, asymptotes want to be hugged. They want to be air hugged. They don't want to be touched. Just air hug. They're yeah, for sure. They're like cats. Okay. Here we go. Now listen. We're going to get 5 points. Okay. Going to go 5 points. Keep your green sheet out so we can have the parent graph. I hope. Okay. Let's look at number 3. Number 3 says h of x equals 3 over x plus 1. There you go. There you go. If you look at the very, very bottom thing you wrote on your green sheet, okay, what does that 3 tell you? Vertical stretch by a factor of 3, right? No, if it was between 0 and 1, if it was a fraction. If it's negative, it's a reflection. What does the plus 1 do? Up 1. Vertical stretch, does anything happen to the x? No, because x goes this way. Vertical stretch, does anything happen to the x? No. Up 1, does anything happen to the x? No. So x stays the same. That helps? Oh, good. How am I going to do the y value? 3y plus 1. Good. 3y plus 1. Go back to your table of values. The x values did not change, correct?
Yes.
So we're just going to use those x values. Now, dang it, I should have had you get your calculator, but we'll make it. Yeah. The y value that did go with -2 was times 3. Just look. No, multiply across. -3 over 2. So that's -3 over 2. And what's -3 over 2? -1.5 plus 1.
Equals half.
-half.
So it just stays the same. We did all of that for it to stay the same.
Did we really?
Yes.
3 times -1/2 is -1.5. That's not negative. Wait a minute. Negative. Yeah, it is.
Wow.
Yeah, it's the day after 10-day break. Yeah, thank you. Thank you for your understanding. 3 times -1/2 is -3/2, which is -1.5 plus 1 is -1/2. Okay, fine. What kind of witchcraft is it? -1. What was the y value that went with -1?
Times 3 equals -3 plus 1 equals -2.
Right. 3 times -1 is -3, plus 1 is -2. Well, what is 3 times undefined?
Undefined.
And what's undefined plus 1? Undefined. Yeah.
Well, we don't know what.
Undefined plus 1.
Yeah. What was the y value that goes with 1? No, what was the y value that goes with 1? A half?
Literally the one that changed.
It wasn't 1. It wasn't a half. It was 1. I thought you said a half.
I just said
Oh, okay.
Four.
Mhm.
Okay, we're not solving here. All right.
Now let's see if I can do this one right. What was the y value that went with 2? A half. Now, what is 3 halves? 1 and a half, and 1 and a half plus 1 is 2 and a half. What'd you say? 2 and a halves.
Still trying to learn English here.
All right.
It wasn't even English.
No, it was.
That's what we're taking the alphabet.
Yeah.
Here we go. Here we go. Is vertical asymptote x equals or is it y equals? Did my x change? What was the horizontal asymptote?
1.
It was 0, but now it's 1.
Okay.
Because 3 times 0 plus 1. Well, no, I mean, because when you multiply anything by 0, you get 0.
Well, like 3y.
Dot in your asymptotes. X equals 0,
Oh, you asked?
y equal 1. Because the horizontal asymptote on the parent graph was y equals 0. And what happened to your y values? 3 times 0 is 0, plus 1 is 1. Okay. Negative 2, negative 1 half, negative 1, negative 1, negative 2, 1, 4. That's off. And 2, 2 and a half. 1, 2 and a half. Now, if you'll notice, there's more space between the points than there was on the other graphs. That's because this one's got a vertical stretch. We're almost finished. We're almost finished. Two more. Okay. You're not completed. I'm sorry. Okay. Let's look at this one. Number 4. F of x equals the opposite of 1 over 2x. Negative 1 over 2x. Okay, so go to the back. Just make sure that you're not writing this on the side that you're going to glue down. That's a good question. Well, just a minute. Now, Angel's asking a real good question. She said, is this a horizontal stretch or shrink, or what is this? The parent graph, remember the parent function was this. What is the parent function of 1 over x getting multiplied by? A negative? No. 1 times what gives me 1? X times what gives me 2x? That thing is getting multiplied by a negative 1/2. What kind of shrink? Here's the deal. This is really negative 1/2 times 1 over x. You see that? So Yes, I understand that the 2 is downstairs, but notice that the parent function is being multiplied by negative 1/2. This 2 is not in with the x. It's not in parentheses with the x. And do you see how I can separate them and say negative 1/2 times 1 over x? This is a vertical. Is it a vertical stretch or shrink? Is it a vertical stretch or shrink? It's a squish. It's a squish by a factor of 1/2. And what does the negative do? Over the x-axis. So you're going to write reflect over x-axis and vertical shrink by 1/2. This is the only one that I think was hard. No, the hard part's done.
Really?
Yep, figuring out what's going on, that was the hard part. If I reflect over the x-axis, does that change the x value? If I reflect over the x-axis, if I go from here to here, does that change my x value? It just changed the y. This point was 2, 3. Now it's 2, negative 3. So, did my x change? No. When I do a vertical shrink, does the x change? So this is still just x. One half y, negative 1/2 y. Yeah, you can get this far. The rest is easy. Yeah, I'm sure. Okay, so let's give it a try. Make your table. The x's didn't change, so let's just keep using those same x's. These are the y values that you have on your green sheet, right? Oh, it's a screw up. Dadgummit. Thank you. Okay. Now let's do this green transformation. I got to multiply this little knucklehead right here by negative 1/2. 1/4. Multiply straight across. 1/4. I know. I know. Still undefined. Negative 1/2. Negative what? 1/4. Okay, let's plot them. Oh, asymptotes. Which one? X equals 0? Yeah, your vertical asymptote is still x equals 0. That's a y, not a g. It was 0. What's negative 1/2 times 0? 0. Your asymptotes didn't change. The asymptotes are only going to change if you do what? Add or subtract. Good. If you add or subtract, that's the only time the asymptotes are going to change. So dot in your asymptotes. And then plot your points. Negative 2. I think I didn't plot my stuff right there very well. Negative 2, 1/4. Negative 1, 1/2. 1 negative 1/2, and 2 negative 1/4. Now you can do better than I can because you got a pencil. Wonky. Here's what I don't want to see. Don't you little knotheads, don't you do something like this and make it like about that long. Because I said, and I'm grading your papers.
I don't go up these things, like you go up.
They, oh, okay. Okay. Is it making sense? Now, listen. Is it it's making dollars? Yeah, smart aleck. Okay. Hey, here's what we're going to do on this one. We're just going to, all we're going to, yeah, I'm sure. All we're going to do on this one is decide what the transformations are and write the new point. Let's look at the transformations. What are the transformations? Reflect over what? Reflect over X. That's what I heard. Reflect over the x-axis, left 3, and a vertical stretch by 2. That's perfect. So let's come up with your point. Does the x change? How? Okay, x changes by subtract 3. What about the y? 2y, negative 2y. There you go. I feel real good that when you get here, you can do the rest of it. Yeah? Okay.